All right, made it to our last page of the review. Number 46. A survey was given to ask freshmen what elementary school they went to. During fourth hour, a survey was given to randomly selected classes. What sampling method was used? So, what we did here is we picked the fourth hour of the day, and then so we're asking freshmen, so let's just say we're at the freshman center. Um, So during fourth hour, we picked randomly selected classes. So maybe we picked room 111 and room 123 and room 201. So because we have people grouped by you know, something in common, I guess you could say, they have the same schedule. So everyone in room 111 in fourth hour, that's a math classroom. They all have math that hour. Maybe room 123, everyone has social studies that hour. And then, and those are, we're randomly choosing classes and surveying everybody in the class. So that's how your cluster sampling works. So we have people grouped, and then we sample or we survey this random group, this random group, this random group. All right, so part B, does the sampling method have any bias? So our sampling methods that are likely to be biased are convenience and self-selected. So cluster sampling is one that is unlikely to be biased. So and another reason is there is some randomization involved, so that decreases the risk of bias as well. Okay, number 47. Given this data set, find the 5-number summary. So what you guys are going to do is you're going to take these numbers, you're going to type them into your calculator, you can enter those all in list 1, calculate your 1 variable stats on it, and then just run through. So the 5-number summary starts out with the minimum value is 2. And then this would be worth your time to, if you're watching this video because you forgot how to do it, actually pause and make sure you know how to do this on a calculator. So the minimum is 2. Our Q1, that's quartile 1, Q1 is 4.5. Your median is equal to 8. Your Q3, the third quartile, is 11.5. And then the maximum is 13. So that's the 5-number summary. If we were to draw a box plot, those would be the 5 numbers we would use. Okay, so calculate the mean. Again, using the 1 variable stats, you guys have your mean. That value is equal to 7.75. So determine if the data is symmetrical, skewed right, or skewed left. So what we're going to do for that is compare our mean and our median. So our mean is 7.75 and our median is 8. So when these numbers are the same or close to being the same, we have symmetrical data. If the mean is larger than the median, then you have data that is skewed right toward the larger numbers. If the mean is less than the median, then you have data that is skewed left toward the smaller numbers. So this is pretty close, 7.75 and 8, those are just 0.25 away. So if we take a look at our data values, if these numbers were all in decimals, like that detailed of numbers, then that 0.25 difference right here would probably feel more significant. But I mean, our minimum is a 2, our maximum is a 13. Our mean and median are only 0.25 away, so I would say those are pretty close to each other in the context of this data set. So that's going to make this a symmetrical data set because the mean and the median are pretty close together. What would be the best measure of center and spread? So when your data is symmetrical, the best measure of center is the mean. Remember, the mean gets pulled all over the place with skewed data. So if your data is skewed, don't use the mean to represent the center of your data because it's just not representative. The spread of your data, if it's symmetrical, the best measure for that is going to be your standard deviation. Standard deviation, we did not go through like the formula for how to calculate standard deviation because we were using our calculators on this. But your standard deviation uses the mean in its calculations. It's kind of like on average, how spread out is your data from the mean. So if your data is skewed and the mean no longer represents your data, then the standard deviation would not either. But with symmetrical data, we would use the mean and standard deviation. If you had data that was skewed left or skewed right, we would use the median to describe the mean and our quartiles. So maybe our IQR, the interquartile range, would be a good measure of spread. Okay, number 48. Consider the following distribution shown to the right. Is it roughly symmetric, skewed left, or skewed right? So if we look at this, we can say, oh, we have all this data here, but then this tail over on the left side. So that data is skewed left. So what can we say about this data? Well, the mean and the median would not be the same because it's skewed. The mean gets pulled toward that skew. So we have these lower numbers. So the mean would get pulled down. So the mean would be less than the median. So just based on the fact that we can see a distribution that's skewed left, we can say a handful of things about it, which is kind of cool. Part B, what would be the best measure of center and spread for the data? So we just talked about that above. I suppose I could have looked ahead to see that we got to talk about it on this question as well. So if your data is skewed at all, left or right, then the best measure of center is the median, because the median is always the middle number. It doesn't matter if your data is skewed left or right. That median does not get pulled around in the same way that the mean does. If your data is skewed, the best measure of spread is going to be your quartiles. And then specifically, we could find the IQR, the interquartile range. And then just a reminder what that is, that's just your Q3 minus your Q1. It's the range of the box of a box plot. That's your interquartile range. All right, last question, number 49. The scores on a test are normally distributed. So keyword right there, we have a normal distribution with a mean of 50 and a standard deviation of 30. Use this information for the following questions. All right, so normal distribution, I'm going to start by drawing this normal curve. Mean goes in the middle. We know that the mean is 50. And then we're going to put in our 3 standard deviations above the mean. Our standard deviation is 30, so we're going to count by 30s. We go from 50 to 80 to 110 to 140, so that's 3 standard deviations above the mean. Now we're going to count out 3 standard deviations below the mean. So if we're at 50 and we go down by 30, we get 20. Go down by 30 and we get negative 10. Go down by 30, negative 40. Okay, now let's see if we can answer some questions about our data. So what percent of data is between the range of scores 20 and 80? So if I look at going from 20 to 80, so here's 20, here's 80. So what percent of data falls in this range? Well, we're looking at our mean is 50, so 1 standard deviation below and 1 standard deviation above. This is going to be 68% of the data. Remember, we have that 68, 95, 99.7 rule. So 68% of the data will fall within 1 standard deviation of the mean. 95% of the data will fall within 2 standard deviations, so from negative 10 to 110. 99.7 of the data will fall within 3 standard deviations of the mean. So because from 20 to 80 is within 1 standard deviation of the mean, that is 68%. All right, so last question. Approximately what percent of data is less than a score of 70? So we're going to do some approximating here. It does say approximately. 70 is not one of these numbers that we're listing out where we have some precise percentages to work with. So if we think about where 70 would be, well, it's going to be between the 50 and the 80, and that's 30 units between 50 and 80. So it's actually going to be about 2/3 of the way to 80. So that is where 70 is. So what percent of the data is less than that? So if I were to cut that off at 70, I want to know what percent of the data is below that 70. Well, one thing we know is that your mean is greater than 50% of the data. So this left half of the curve, that is 50%. So for sure, we're greater than 50%. But then we have this part, let me see if I can highlight it in a different color. Then we have this percentage right here to add on to the 50%. So from 50 to 80, that's 34% of the data. So it's not quite 34% of the data. It's going to be, a little bit less than that. So just kind of generalizing, maybe 25% of the data is between 50 and 70. So if we add those together, we're just estimating that what percent of the data is less than a score of 70? Maybe about 75% of the data. Again, we can't get super exact, but we can get a decent estimate. If we had said like 52% of the data, that would be a data value that's closer to the mean. If we had said 79%, or if we had said like 83% of the data, that would have been closer to the 80. So I feel good with an estimate of 75%.